Normal distribution. So the length of a snowboard that a person would use is related to their height and their weight. The histogram below shows the heights of people that commonly rent snowboards at a ski shop. Draw the frequency polygon on the histogram below. Describe the shape of the frequency polygon. Okay, so we're going to drag this down a bit. So remember, a frequency polygon, what we do is we put a dot in the middle of each bar. So put a dot in the middle of each bar, because we're using that dot to represent the the particular height. Okay. In this case, we actually have the heights to the nearest centimeter. So we put dots in the middle of each bar, and then we join them with straight lines. So just go from one to the other, draw a straight line. You could use a ruler if you wanted, but freehand is okay. Okay, so I'm not trying to draw a smooth curve or anything, I'm just joining those points, right? So at the top of each bar, we put a dot, and we're going to use that dot to represent that data. And then we join them with straight lines, okay? So we call it a frequency polygon because it's going to have a lot of different sides, right? Where each straight line is sort of a side of that polygon. Now, what kind of shape do we get? The shape. So it's this shape. Okay, so it's the Datasaurus. Right? It fits with this lesson, right? It's got the normal distribution on it. So normal distribution is a bell-shaped curve, right? So it's bell-shaped. Okay, so if you think of a bell, big in the middle, trailing off towards the edges, that's called the bell-shaped curve, or the normal distribution. So the bell shape for the frequency polygon indicates that this data is normally distributed, right? So when you see a bell-shaped curve, that tells you the data is normally distributed, right? And we're going to go through, well, what does that all mean, right? Which means that the lengths of the snowboard renters in this shop follow a normal distribution. Okay, so it's called the normal distribution. And there's a lot of data that we collect which follows this normal distribution. Now, number two is use the midpoint of the interval to determine the mean, median, mode, range, and standard deviation for the snowboarder's height. So we're actually going to have to enter this data. Okay, so you see we've got 61, 62, 63, and so on, and then we've got the frequencies here. So they're listed for us. So in L1, we're putting these numbers, 61 through to 79. And in L2, it's going to be these numbers. Okay? So I'm going to pause this because we're going to take a minute and do that. And it's going to take a minute to do that. And then we'll come back and we will run the statistics on it using the calculator. Okay, so calculator's out. Okay, so we've gone through, entered all the data. The x-axis, or the independent variable, is L1, and the y-axis, or dependent variable, is L2. Now we want to run one variable stats, L1, L2. So remember, L2 is the frequency list, right? It's how many times this occurs. And L1 is the height, right, in inches. So 61 inches would be 5'1". Okay, and 79 inches would be 6'7". We know there's not a lot of 5'1" people out there. There's not a lot of 6'7" people out there. There's 5'1"? Okay. Well, there's not a lot of you out there. 6 feet. Hello. But there are some. There's not a lot of 6'7" people. There are a couple running around the school, I think. Okay, so we go to stat, calc, 1var stats. In this calculator, it's L1, frequency list is L2, right? Second function L2. On an 83, without this, you go 1var stats, L1, comma L2. So you're telling the calculator the observations are in L1 and their frequencies are in L2. Right? Okay, seriously. Okay, and then we're going to tell it to calculate. Okay, and we've got the answer, right? So X bar, I mean, you keep talking, you're out of here.
You didn't know what you said.
Oh, yeah. Okay, what I said was, you keep talking, you're out of here, okay? Not putting up with it. Because if I came back to look at your calculator, what would I see? I don't even have my calculator. Fine. Okay, mean 70.02. Median. Where's the median on here? Got to go down further, right? Now, one thing we can look at is n is 1,000. I don't know if they told us there were 1,000. Somewhere on there, if they said this is the height of 1,000 snowboarders, but okay, they didn't say that, but we at least know, right? Like what you don't want to see for the n value is something like 20, right? Because that would just be your height. What it would mean is you didn't tell the calculator that L2 is your frequency list, right? So use the n value to check. Okay, median is 70. The mode, what's the mode? So where do we get the mode from? The mode is the most frequently occurring, or the highest frequency. So what's the mode?
147.
So 147, but the mode is 70.
Oh.
Okay? I mean, you kind of notice if you try and fill 147, there's like, wow, the mode is like, oh wait, that's the number of times it occurred. What I need is it. Oops. Yeah. And I'm on to the next page. Okay, so the mode is 70. You notice they're all pretty close together, right? The mean, the median, and the mode. That's actually a characteristic of the normal distribution, is that the mean, the median, and the mode, they're all in the middle, right? I mean, the middle is the median. The mode is the most frequently occurring. You got that bell shape, so the most frequently occurring will be in the middle, and then the mean is also in the middle. Our range, now what's range? Is it like something dash something, or is it a single number? I'm going to take a vote on this.
17 minus 61.
Yeah, you take high minus low. Range is a single number, right? So for high minus low, we got max of 79 and a min of 61. So it's 79 minus 61. The range is 18, right? That's how we get it, but it's not 79 minus 60. It's not 61 to 79. It's not expressed as it goes from here to here. It's the value over which the numbers go, right? Standard deviation, that's the little sigma. That's this guy. Okay, so 2.98. Let's go to like 2 decimal places. And the number of renters is 1,000. That's our n value, okay? Now I'm going to assume we all have the same numbers, right? On a test or something, you should double check and make sure that your numbers are entered correctly. I mean, nobody said, oh, wait, I got different numbers for these things. Okay, and assuming that you followed along with this, we all have the same numbers, right? So, but on a for real test or something, just go back through and make sure, take time, just go back through and say, okay, 6, 5, 6, 2, 3, 4, 5, okay, yeah, those go up, and 3, 4, 10. Just match it up again. Complete the following table. Okay, so the mean is 70.02. And the standard deviation is 2.984. Let's add one more decimal there. 2.984. And now we got these various little symbol thingies here, right? This is the mean minus the standard deviation. So 70.02 minus 2 points. So I'll fill these in for you, right? You don't have to calculate them. That's just a, I'm going to assume you can use your calculators to do this. So 67.036. The mean plus the standard deviation. Okay, so that's 73.004. The mean minus 2 times the standard deviation. So my order of operations says, if you just enter it in your calculator as the number minus 2 times this number, you'll get the right answer, right? Because your calculator will do the order of operations. 64.052. The mean plus 2 standard deviations. 75.988. The mean minus 3 standard deviations. 61.068, and the mean plus 3 standard deviations, 78.972. Okay, so give me a moment, get all those numbers copied down.
How do you define standard deviation?
Okay, so standard deviation was out of the calculator, right? That's stat calc. One of our stats. Now, your calculator is going to default back to the last thing you did, right? So if you have to do one of these where you're not doing a frequency list, you're going to have to change that to blank. Okay, so just be aware of that. Okay, and then, so there's our mean, there's our standard deviation, right? Both of these came out of the calculator. So it's determine the number of renters within 1 standard deviation of the mean. So within 1 means, what are the number of renters from 67 to 73? Okay, so, all right, let's go back. So 67 to 73. Okay, so we can add these up. Right, so 64 plus 116 plus 128 plus 147 plus 20 plus 115 plus 63. Well, actually, there's something else we have to do here, right? Something we got to do, which is we got to say, well, we're not really going from down here, right? The middle is what's representing 67, right? The middle of it, because frequency polygon that goes through the middle. So we're just going to take half of the 64 bar, right? Because that's the middle, right? And that's what we want, is this is where your 67 is, this is where your 73 is, okay? So let's go over here and we'll write that down. So we're saying we need, so in between 67.036 and 73.004. So we need a half of the bar with 64. Plus the bar with 116. Plus the bar, and if you're looking at your page as opposed to up here, right, you can see the numbers there. So plus the 116, plus 128, plus 147, plus 129, plus 115, plus 1/2 of the bar with the 63. The 73 bar, which has a 63 up there, right? That's the occurrence. Right, but we're saying, remember, we're going from the middle. Frequency polygon, you put the dot in the middle. So it's the middle of that bar that represents 67. Right? The other numbers are a little below 67 and a little above, right? From 66.5 to 67.5. Okay, and that is 699. It's about 699. So about, I can say with equals a little dot up top, so that says about equal to 699. And if we divide that by 100, we will get, oh, sorry, 699. Divide that by 1,000, right? It's 699 out of 1,000, which is 0.699, which is 69.9%. Okay, so we're saying around 69.9% of the data lies within 1 standard deviation of the mean. Okay. Now, whenever we say lies within blah standard deviations, we mean from the mean 1 standard deviation below from the mean, 1 standard deviation above. So within 1 standard deviation of the mean is, okay, here's the mean, which is right there going through this dot, and within 1 standard deviation is from here to here, from 1 below to 1 above. Within 2 standard deviations of the mean, okay, so go back here, within 2 is going to be from 64 to 76. So 64, we're going to go here, and 76, we're going to go here. So this was within 1 of the mean. Okay, so when I use sigma, just read that as standard deviation, right? This is within 2 of the mean. Did anybody wish you a good? I should have wished you. Sorry. Good man. How could I? With this T-shirt though, and this thing, right? Like matches the T-shirt to the lesson. Come on. Okay, so within 2, right? So in between 64.052 and 75.988. Okay, so the numbers are a half of 18 plus 30 plus 50 plus dot dot dot, right? I mean, there's other numbers in there. I'm not going to write them all in there. Yep.
Why did you tell me percent number 4?
Well, if we say how many renters, say 699 renters, that doesn't really mean much to us, right? If we change numbers to percents, right? It's like saying, oh, you got 24 out of 30 on the test, right? It's like, okay, I think that's pretty good. But if I express that as a percentage, oh, yeah, hey, that's good, right? So that's why we always change marks on tests where we change those to percentages, right? Because we can all identify, we know, okay, that means that about 70 out of 100 people are within that 1 standard deviation, right? Instead of saying 699 out of 1,000. Right? So change it to a percent. Percent, remember, is just French for out of 100. Okay? And it's a number that's pretty easy for us to identify. It's because we've done it a lot. Plus a half of, okay, so if we go back here, we're taking a half of this bar, right? A half of 20. So we started with a half of the 18 bar, added everything else up, and we end with 1/2 of the 20 bar, okay, which is 945 out of 1,000, which is 0.945, which is 94.5%. So of the renters, we could say 94.5% of them lie within 2 standard deviations of the mean. And within 3 standard deviations of the mean, so that's this guy, so 61.068, so 61 to 79, really, right? So from 61 to 79. So remember, 61 or 79 is represented by this middle dot. Okay? So this is within 3 standard deviations. So actually, the easy way to count this would be to say, well, what don't I want? I don't want to count this, and I don't want to count this, and I know there's 1,000 in total. So we just subtract off half of 3. Right? So this is in between 61.068 and 78.972. Okay, so we could do half of 3 plus 4 plus 10 plus dot 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 plus and end with 17 plus 5 plus a half of 2, right? Or we could say, wait a sec, we know there's 1,000 people, and we're going to take from that half of 3 plus half of 2, right? We just take away those 2 little end bits, right? Half of the bar that has 3 in it on the left end, and half of that And that works out to about 997 out of 1,000, or 99.7%. Okay? 99.7%, that's almost everybody, right? Almost everybody lies within 3 standard deviations of the mean. Okay? There are still 0.3%, right? Or 3 out of 1,000 that don't lie within that, right? But out of the 1,000 renters that we had, only 3 of them are outside of this range from 3 standard deviations below the mean to 3 standard deviations above the mean. Right? And you will see this distribution occur over and over. It'll be in test marks. It'll be in your heights. It'll be in your weights. Right? I mean, if we do height by males and females, we're not just mixing everybody together, right? But we say, we take all the males. You're going to follow this normal distribution. You can see that walking around school, right? It's like, there's some really tall guys out there, right? And there are some really short guys out there. Okay? So they're on the extremes of the distribution, right? Down here in the tails, the low end and the high end. You can do the same thing with scoring hockey goals or something like that, right? There are people that score a lot of goals. There are people that don't score goals, right? But most of the players lie, you have this bell-shaped curve, right? And most of the data. Okay, so all data that is normally distributed has the following characteristics. The mean, the median, and the mode are all the same. Okay, so you look at that bell and you say, well, where's the middle? Right there. Where's the mean? In the middle, right there. What's the most frequently occurring? Well, it's a frequency polygon right there in the middle, right? Mean, median, mode, all the same. The graph of the distribution is shaped as a bell. The graph of the distribution is symmetrical about the mean, right? In other words, you could reflect one side on the other. Symmetry of 2 ends? Yeah. Metrical about the mean. Okay. In other words, you could draw a line on the mean, fold it, one half would lie right on top of the other half. Approximately, and I'm going to fill in the actual for reals numbers, not the, approximately 68% of the data lies within 1 standard deviation of the mean. Okay, a little over 2/3, right? So that's anything that has a norm. It'd be shoe size, whatever. Right? If we took the average shoe size, right, it would follow that graph. Really small feet out there, some really big feet out there. Most people, as a matter of fact, 68% of them will lie within 1 standard deviation of the mean. Approximately 95% of the data lies within 2 standard deviations of the mean. And 99.7%, 99, so 997 out of 1,000. That's one time you might want to turn a number instead of a percent to say out of 1,000, right? Because 997 out of 1,000 means something to us, right? I mean, there are 3 people that aren't, right? Like there's 3 things that are not within. If there were 1,000 people, and this scales up or down, right? If there were 1 million people, well, it's proportional. If there were 1 billion people, right? There's 7 billion people on Earth. We can figure out, well, how many would be out in the. Now, if you're talking 7 billion, you're going to get a significant number, right? But if you're talking the school, it's going to be it's like, well, there's 3 people here, right? So let's say there's 1,000, and there's around 1,000 people in the building. Okay, it's probably a little bit over, but it's around 1,000 people. So then we'd say 3 of them are outside of that range, right? Like higher than 6'7", lower than 5'1". Data lies within 3 standard deviations of the mean. So that's called the 68, 95, 99 rule. They tend to say 99, it's really 99.7. So 68, 95, 99.7 rule. So here's the rule, right? 68% within 1. Now, in this case, we're using mu for the mean. Right? Remember, calculator uses x with a bar. We use the letter mu. If we use it twice, it's mu2. But we'll get into that. Okay, so 68% of the data lies within 1, right? Mu plus 1 sigma, mu minus 1 sigma. That's how we represent it, right? 95% of the data, mu plus 2 sigma, mu minus 2 sigma. 99.7% mu plus, 3 sigma, mu minus 3 sigma, right? Mu, mean, x bar, that's what your calculator shows. That's what we use, right? Calculator. What we use. Both calculator and what we use. So the sigma, that's in the calculator and it's what we use, right? Both of those are the same. Calculator uses x bar, we use mu. Okay, for talking means. Used a normal distribution curve to determine each of the following. What lies between 1 standard deviation above and 2 standard deviations above? Okay, so here, let's mark this with a purple asterisk and say from 1 standard deviation above to 2 standard deviations. Okay, what percent is that? 13.5. So 13.5% of the data. Okay, let's switch to red. Between 1 below and 2 above. Okay, so the red, I want between 1 below and I want to go to 2 above. Okay. 68 plus 13.5, so 78, 81.5, right? 81.5. Just double checking. So 81.5%. Between 3 below and the mean, right? These should all be mu's. Mu, mu, mu. Not to get catty or anything. Mu, 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 and mu too. So where were we? Oh, I'm going to switch to green now. So green doesn't help you if you're red-green colorblind and you're watching this. Between 3 below and the mean. Okay, what percent is that? 34 plus 13.5 would be 47.5, 47.85, 49.85. Okay, so 49.85. 49.85. Remember, these are approximations, right? It's a little different. And let's use blue. Lies between mu and mu plus 2 sigma. So blue between here and here. Okay, so that's pretty easy, right? Just got to add those 47.5%, right? 47.5. Okay, so that's just using that approximation, right? Again, this says general normal distribution curve is shown. These are approximately, okay? Not quite exact, but it's pretty close. Examples. Label the following normal distribution curves with a horizontal scale given the mean and standard deviation. Okay, so the mean is 25. The mean goes in the middle, so this is 25. What number goes here? 28, right? The mean plus 1 standard deviation. What goes here? 31. What goes here? 34. What goes here? What goes here? Okay, so this is the mean, right? Mu. This is mu plus sigma. This is mu plus 2 sigma. This is mu plus 3 sigma, right? So we're going to say, okay, you gave me the mean, you gave me the standard deviation. Okay, here's the mean. This will be a little bit tougher because we've got some decimals going on. So the mean, where do I put the 60.3? In the middle. What goes here? 61.8. What goes here? 63.3. What goes here? What? Oh, what did I say it should be? 3. 63.3. Okay, so what goes here? Okay, use your calculator, right? That's why your parents laid out all that money. What goes down here? Okay, somebody use the calculator. 58.8. You were right. What goes here?
57.3.
And what goes here?
55.8.
55.8. Okay, you got the mental math going on there. It's good. Use your calculators, though, right? There's no point getting something wrong because you know trying to do it in your head. And okay. So again, if we have these distributions, I said, what percent of the data lies between 22 and 28 here? You'd say, oh, well, that's within one standard deviation, 68%. Right? Okay, so we've got that going on. I think there's 2 more to do. Whoops, wrong way. Okay, 2 more. So you label these now, right? You should be able to do these, and then I will give you a head start and lag behind you, and I'll write them up when as soon as I see Miriam's done. I'll start writing the numbers up. Okay. You'll be waiting a long time.
Does your mean 0 is the same?
What?
Does your mean 0 is the same?
What do you mean it's the same?
Like you do -1, -2, -2.
You got to go down one, right? Yeah. So the question is, if the mean is 0, do you do the same? Yeah, you add 1 sigma, 2 sigmas, 3 sigmas. Okay, so, I mean, this one's almost trivial, right? And this one, okay, don't need a calculator. You shouldn't need a calculator for this, right? Okay. So, there's those 2. Give a little check. So, that the right-hand distribution, along with the mean of 0 and the standard deviation of 1, that has a special name. It's called the standard normal distribution. Okay, and what it allows us to do, I haven't read the notes ahead yet, so I'm probably jumping in and stomping on something that I should have looked at. But what it allows us to do is to compare different distributions, right? Like, so we got a math class, right? Math class has a certain mean and a standard deviation. And you're also in a chem class, and it has a certain mean and standard deviation. It's going to be a different mean, different standard deviation. And you want to compare, where am I on the curve? So what you do is you convert those different distributions so they have this standard distribution, right? We'll be going through this at some point. And it allows you to compare to 2 different things, right? It would allow you to compare, hey, how did I do on the math diploma exam as compared to the English diploma exam? Where am I on the curve, right? And it allows you to compare different distributions. So this is one we're going to see again. But before we get there, Janine surveyed the battery life of her friends' iPhones and asked them to record how long the battery lasted before being charged with a lot of usage. Her friends came back the next day and gave her the following times in hours. Does the data approximate a normal distribution? Justify your answer by determining the mean, the median, and discussing the significance of the values, blah, 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 right? So, okay, we are going to have to enter this data into our calculators, right? We're going to have to enter this data into our calculators. So
do we have a lot of L's?
You're going to put them all into L1, right? Because each of these numbers occurs once. Okay? We don't have a frequency table. We haven't split them up and said, hey, let's work this on, from here to here. We just got a bunch of numbers, right? So Turn calculator on. You go second function 4, which is memory. Number 4 is clear all lists. Hit enter. Clears your lists, right? Stat, edit, into L1, right? All of those into L1.
It's gonna take 5 hours.
Well, by then your phone should still have a charge though, based on the chart, right?
All of them?
All of them. So just I would just go down the row, right? 7 points. So you've got it in front of you. Don't look up here. Look down at the sheet in front of you, right? It's gonna be easier to work off of that. Okay, so our check that we did this right is we're all going to get the same numbers. If I have different numbers from most of you guys, then I entered something wrong. Okay, and same deal. If you have different numbers from the most of it. Now on a test, we're not going to ask you to do this with like 40 different numbers, right? But in class, we can ask. So I'm just going to pause this. There's no point in recording. All right, so I'm just not good at entering the numbers. We're going to let the students enter them, and we will. Okay, so what you want to do is run a 1-bar stats on just L1. Okay, so if your calculator has one where it says frequency and it's got L2, just hit clear or delete on that, so that it'll say your list is L1, frequency is clear, and then calculate. Just say calculate. If you're using a TI-83, just go 1-bar stats, hit enter. Right, it defaults to L1. Okay, what do we get for a mean? 2 decimals. 7.86, okay? Now, it's in hours, right? Because this table chart's in hours. And what do we get for a median? 7.90? Okay, so how many data entries are there? 1, 2, 3, 4, 6. So like 30 of them, right? So if there are an even number of things, like 10 or 30, the median is a calculated value. You got to take the 2 middle numbers, add them together, divide by 2. That's what the calculator's done. So we say 7.9. There might not even be, I mean there is, but there might not be a 7.9 in the chart. Okay? If there's an odd number of numbers, like 9 of them, then there is a middle. So the median, if there's an odd number of numbers, the median is one of the values, right? And if it's an even number, it might be one of the values, but it might be different. It might be a calculated value. Okay, so these are pretty close to each other. We can assume, all right, maybe we have a normal distribution. Well, it's suggesting it, right? So, determining the standard deviation, and so what's the standard deviation off your calculator? 1.51, okay? Determine the standard deviation, and then determine the percentage of values within each of the intervals, right? So these guys being close suggest maybe it's normal. Like if they were really far apart, we could say that's not a normal distribution, right? Because I know it's got to have that bell shape, which means the middle, the median, and the mean need to be the same, okay? We got a mode as well, but we're not, I guess we could look up here and say, hey, does 7.9 occur a bunch of times? It seems to occur fairly frequently, so that kind of, well, maybe the mode is also 7.9. Okay, so the mean plus the standard deviation plus or minus, right? So we've got 7.86 plus or minus, means we've got to do 2 operations. We've got to add 7.86 plus 1.51, and we've got to subtract. Okay, so subtracting, let's do that first, gives us a low 6.35, and adding gives us 9.37. Okay, so if you want, I'll do all these calculations for you. You don't have to do them, right? I mean, we're going to assume you can add and subtract numbers on the calculator. This will be 7.86 plus or minus 2 times 1.51. Okay, and that gives us a low of 4.84 and a high of 10.88. And this gives us 7.86 plus or minus 3 times 1.51. Gives us a low of 3.33 and a high of 12.39. Now, what we want to figure out is, Okay, it says determine the percentage of values within each of the intervals. So how many numbers are between 6.35 and 9.37? So we could go, we could count that, right? Okay, it's like one of those cooking shows where now I'm just going to pull the pie out of the oven, right? So it's going to give you the numbers. We don't have to actually. But there will be examples you have to do where you actually have to go and count them, okay? But I'm going to count them for you. So there are 21 out of the 30 values, which is 70%. So 70% of the data lies within one standard deviation of the mean. And the fact that the mean and the median are pretty close to each other is starting to tell us, hey, this is probably a normal distribution. If we count these guys, we're going to see that 29 out of 30, which is 96%, lie within 2, right? Remember, 68, 95, so that's close to 68, that's close to 95. And 30 out of 30 lie within this range, or 100%. Okay, so we're supposed to have 68, 95, 99.7. These are all pretty close. Okay, so it's likely that this data is normally distributed. Okay, so all percentages, these percentages, all of these percentages are close to the normal distribution. I can abbreviate as DIST. Okay, what we're going to do now is complete the frequency table below and draw a histogram. So that means I need some intervals, right? And if we look back at the normal distribution, what do we got? 2, 4, 1, 2, 3. So we got about 6 intervals in a normal distribution, right? Within 1, within 2, within 3 standard deviations. And we know that all of our data here actually lies within 3 standard deviations, right? So what we're going to do is split this into 6 intervals, okay? So we're going to go with an interval which represents x minus 3 sigma, or sorry, mu, mu minus 3 sigma, mu minus 2 sigma, mu minus sigma, mu plus sigma, mu plus 2 sigma, and mu plus 3 sigma. Okay, and then the mean kind of lies just kind of here, right? There's the mean, and we go mean minus 1 standard deviation. Okay, so the numbers we're going to use are this. For mu, we're going to go 6.5 to 8. Okay, we're going to go 5 to 6.5, right? Because remember, our standard deviation is 1.5, right? So we're going to go 1.5 away. And the mean, and 3.5 to 5 up here. We're going to go from 8 to 9.5, right? The mean is close to 8, right? So we got kind of 8, and this is 6.5 to 8. This is 8 to 9.5, right? Because we're not going to use the 7.86, right? So we're just going to go with numbers close. Mean's about 8, and standard deviation is 1.5, so we'll go, 6.5 to 8. That'll be mu minus sigma. Okay, 8 to 9.5, 9.5 to 11, and 11 to 12.5. Whoops. And 11. Okay, now you've got a tally and then you've got a frequency. So this you got to do, right? I'm going to make you do this. I'm not going to make you do that. You can walk around, but you should do this. So go up here, and here's what you want to do. Take each of the items, so 10.5, right? So I'm going to deal with 10.5, and 10.5 is in here, so I'm going to put down a tally. So you do a tally chart, you go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and so on, right? That's what you're going to do in this column, is you're going to look at the top, you're going to say, okay, the 10.5, cross it off to indicate I've dealt with it, okay? Then the next one down is a 7.7, so where's that? Goes here. Okay, cross. I'm not going to do all the cross-offs because it's up there. I'm not going to scroll the thing up and down all the time. Actually, I could probably shrink it. Let's do that. View, zoom, entire page. Okay, so I got the entire. Okay, so 7.7 done. 8.4 goes in here. 7.1 goes in here. 6.8 goes in here. And I got to blow it back up again because I'm going to run out of space and I'm making, tick marks that are whatever. But you do your own.
See how big these
Okay, and then we will compare. So just make sure, right? So it's getting bigger, and so I'll give you more. Just go through, right? It's good practice.
This year is so easy.
It's not like it's hard work or anything, right? But you don't want to be doing this for the first time on the test, right?
Yeah.
Okay, you want to at least have some practice with this. Maybe, I don't know, it's on your outline, right? Like, what do I memorize these things?
Then next Monday.
Next Monday.
Why do you always have tests on Monday?
I don't know.
like this coming up Monday.
Oh, no.
15th. So no,
Oh,
this
the
comes
week
because we don't remember we don't have school tomorrow or Friday, right? So you got a couple days off to do some normal distribution homework, right? Normal distribution.
Yes. Oh, are we done?
No.
Oh.
Done. Well, that explains the. Do you have the sheet in front of you? Apparently not.
So you see how you have 9.5
We were done.
twice? What if it's like right on 9.5?
So what if it's 9.5? So that means one of these intervals has to include, right? So if I say 3.5 to 5 and 5 to 6.5, then which one includes?
You put it in both?
No, so you don't put it in both. You okay? I gotta see. I think what happens is the low end includes and the upper end does not include. So the 9.5s go in here, not in here. Try that. Let me know what you come up with as a number, because if it's different, then we'll switch it. Yep. I have numbers down here, so.
I don't like this. Alright. Too much custom. Okay.
6.5 to 8 is gonna get filled up.
Yeah, there's a lot, right? Well, it's in the middle, right? Anything in the middle is going to be, 6.5 to 8 is going to be pretty big, because that's the middle, includes the mean, right? Because the mean is in there.
What if, so it's not a normal distribution if, wait, Daddy,
Yeah,
it's not normal distribution if it doesn't make a bell sound?
right. Bell sound. No, they don't sound like anything. Bell shape.
Okay.
Let's separate our colors from our shapes from our sounds. So if it's not red, is it normal? I don't know, man. It's a color. It's got to be the shape. It doesn't sound like a bell. Is it normal? No, that's the sound, not the shape.
Why not? Just show it some
But I gotta mark how late. What time did this period start? Because it's about an hour, right? So yeah, it's like an hour, 60 minutes.
Better late than never.
Going to U of A. I'll check at U of A. Did he make class? Ooh, haven't seen him. Okay, so these numbers agree with your numbers?
Yeah.
Good. They're just saying it. They haven't done it.
Hey.
Did you actually? Okay. Did you actually do it?
I didn't do it like that.
Did you actually do? You have that chart filled in? If I come back there and look,
Seeing that they make sense.
will I see these numbers?
Yes.
Okay.
No, no.
Oh, called their bluff. Did everybody do it? You got these numbers? Okay. So the thing here is that the lower end of the interval includes the number and the upper doesn't, right? So the 9.5 goes in here, not in this one. Okay. So lower includes, included, and not included. Okay, so if we had like 2 decimal places, 9.49 goes in here, 9.50 goes in here. Okay, but we don't. So now what we want to do is we want to draw a frequency distribution. So we say, all right, well, the biggest one is 13, right? So I'm going to go like 5, 10, 15. Okay. Now all we're doing is kind of a rough sketch of the frequency distribution, right? We're not doing a full thing here. So my intervals are 3.5 to 5 is 1. So that's 5, so that's about 1. 3.5 to 5. Now what I want to do is make all my bars the same width, right? Same width. And then their height is represent, well, 5 to 6.5 is 4. So 4 is about here. So 5, this is the interval 5 to 6.5. Next interval is 6.5 to 8 is 13. So 13 is about here. 6.5 to 8. Okay, so these bars should be about the same width, right? I'm not going to take a ruler on a test and measure your bars, but you know, don't go drawing one like this. Oh, here's the next one. Okay, so you know they should be about the same width. Okay, next one is 7, 8 to 9.5. So 7 would be about here. So it'll be 8 to 9.5. Then we got a 4, so that should be just basically the same height as that. And that's 9.5 to 11. And then we got a 1, 11 to 12.5. Okay? And you can put the numbers here. Okay? You put the numbers on top just to indicate, right? So if I can't read, if we don't have a grid line, you know, like to do this properly, we need grid lines 1, 2, 3, 4, 5, 6, right? And then it'd be easy. You can get the frequencies right because you have a grid line to draw on. So I don't, I'm going to put the numbers up top so we can see. All right, yeah, you got a 1, a 4, a 13, a 7, a 4, and a 1. Okay, and you can see we have a shape that is basically a bell-shaped curve. Okay, that the mean, the median, and the mode are all kind of in the same place, right? Most frequently occurring. That the mean lies in there, right? Remember, the mean is somewhere around here. Okay, but this bar represents halfway between. Okay, so we do lose some information, right? Like I know there are 13 numbers between there, but I don't really know what they are. We're using the middle of the interval is going to end up representing all 13 numbers, right? We're just going to say, on average, those 13 numbers are going to be this. Okay, it's not really true, but it's close, right? The average won't be far away. And when you get a large enough set of data, right? So if we look at all the 30-2 students in the province writing, then we're talking thousands of people, right? So that it really does, and you'll get this kind of curve. Okay? You get a normal distribution. Okay, one more page. It's called the Datasaurus. Right? It's got this, right? And it's like the appropriate shirt for the day.
Where did you
Where'd
get
you
it?
find this shirt?
ThinkGeek, I think. No, ThinkGeek. I ordered it online. I saw it and I thought, hey, math t-shirt. And then today, hey, normal distribution lesson. Where is it? I actually pulled it out of the plastic bag last night. Okay, so one more page, right? 10. The number of years of teaching experience for the staff members of a high school in the south end of the city is normally distributed with a mean of 15.5 years and a standard deviation, but they said with, whatever. A 4.5. Sketch a normal distribution curve and label the horizontal axis appropriately. Okay, so what you want to do is just draw a bell-shaped curve. Okay, and then if you flick it, it'll sound like that. Cue sound effect. I should have had a sound effect queued up on my phone with a bell. Okay. Now, actually, it's slightly. Whoops. Okay, now there's another characteristic of the normal distribution, which is the ends don't actually ever come down and hit the line, right? The ends don't ever come down. So it doesn't close off, right? There's always a possibility that there is something way out there, right? Not on a test. I mean, if it's a test, then 100 is it, right? It's 0 to 100. The marks have to fit there. But in anything like height or whatever, there is somebody who's like 8 feet tall, right? Like they're way out there. There's not a lot of them. It's like out of 1 billion people, there's 2 or 3 maybe, right? Or out of 7 billion people. There's not that many people in the world, right? But they're like on the curve. They're like 5 or 6 standard deviations out, right? And you know, you got little people, not just born little people, but fully mature, and they're out there, right? I don't know what the technical term is. Could be.
You don't like that word.
Well, there you go. So, okay, so yeah, this YouTube video is gonna hit with whatever heightest math teacher. No, I said heightest. Height S. Okay, the mean is in the middle is 15.5. 1 standard deviation above is 15.5 plus 4.5 is 20. 2 standard, now these widths are the same, right, or supposed to be, right? Each bar on this, the normal distribution is the same.
How many bars are supposed to go?
24.5, so 1 standard, 2 standard, you go up to 3, which is 29. You go 1 below, so 15.5 minus 4.5, which is 11. 2 below, 6.5. And 3 below, which is 2. Okay, now here's the actual numbers. The actual percents. We said about 68%. It's really, there's 34.13%. Okay, in each of those. Right? Now there's a way your calculator can do it. We'll get into that later, so you don't have to memorize these numbers. Okay, but I'm just writing them in there for you. There is some stuff on the formula sheet. So 13.59% in each of these guys. Okay, remember it's symmetrical, right? So if there's 34% here, there's 34% over there. There are 2.14% between 2 and 3 standard deviations, above or below. And in the tails, 0.14%. Okay. So out of 100 people, that's 1.4 in each tail. You say, I don't like 1.4 people. So out of 1,000 people, that's 14 in each tail. Right? Out of 1 million people, it's whatever that works out to. You know, you have to multiply by some number, which I can't do in my head, and I'm not good. Okay. Out of 1 billion people, you can see there's actually a fair number of people. If you're talking 1 billion people, there's a fair number of people there, right? Then we're talking, you know, the population of India or something, right? 1 billion people in North America doesn't cut it. Rounded to the nearest billion, there are 0 people in North America. If there are 85 staff members, then how many teachers with between 11 years and 20 years of teaching experience? So we need from here to here, right? From there to there is 2 times 34.13%. To 68.26%. Okay, and what we want is 65.8. Now what we do to, I don't multiply by 68.26%, I multiply by the decimal, which is 0.6826. So 85 times 0.6826 is 58.021, or 58 teachers, right? I mean, if we're talking things that only come in whole numbers, then we need to round. Okay, so about 58 teachers. How many teachers have less than 2 years of teaching experience? Okay, so less than 2 years, right? So where is less than 2 years on here? Right, there's 2 years. Less than 2 years is this one, 0.14%. Okay, so 0.14%, which is 85 times 0.0014. You have to convert this from a percentage to a decimal. Okay? Which means you need to divide it by 100, right? This is out of 100, you got to divide by 100 to convert it to a decimal, which is equal to 0.119, so we'll say 0 teachers. Okay, so there's nobody on the staff that has less than 2 years. Okay, or, you know, maybe one at most. Okay, so there is a small number. So you say, well, 0, there could be 1. More than 20 years of teaching experience. So more than 20 is from here. So it's 13.59 plus 2.14. Okay, so 13.59 plus 2.14 plus 0.14. Those are all, that's a percent. So it's 15.87%. So as a number, 85 times 0.1587. Remember, percent means out of 100. It's 15.87 divided by 100, which is 0.1587. And this works out to 13.48. So we say 13 or maybe 14.
Would it be 13?
If I asked you for a distinct number, you'd say 13, but you know, I wouldn't be surprised if it was 14, right? So remember, this, you know, it's not exact, right? Like you need a lot bigger numbers than 85, right? Like what we have to do is say, okay, there are 40,000 teachers in the province. Here's how it works out, right? And then we would get better numbers, right? So the larger your data set, the better your numbers.
Oh my goodness.
Do question 9 on page 280 together as a class.
No, wait, there's a lot repeating, but still no.
So, okay, look, they're in numerical order, so it's not as hard as you think it is to do,
We
right?
don't even have a graph on our page.
You don't have a page 280 in your book?
Oh, in the book?
No.
Oh, yeah.
If you went to your textbook and turned to page 280, you wouldn't see
I'm just
this.
leaving this.
No, I know you don't have this. You have this on page 280 of your textbook.
Would that all take L1?
Well, so what you do is this, right? You say L1, my numbers. I'm guessing this is a typo and it's 68.
That's 38.
Oh.
You look it on page 280, it is 38. You could look on page 280. Is that even a math book? Oh, it is. That's amazing. I actually got the math book out. That's not a science book or something. Go to page 280.
Yeah, it's 68.
68, okay. So that was a typo on there. So if we look at this, we say 65 is once, 66 is twice, 67 is twice, 1, 2, 3, 4, 5, 6, 7, 8. 68 is 8 times 1, 2, 3, 4, 5. So what I could do is make a little chart, right? We just got to count it out. So I'll give you the numbers, right? Just to make life a little bit simpler. So L1, you have the numbers. And L2, we're going to do the frequencies. So we're going to make a frequency table, right? So you've got two choices, right? You could just enter all these numbers in, right? There's 200 of them. You could just enter 200 numbers into L1. And you say, there's no way I'm doing that, right? So instead you say, okay, well, so what is it, right? So 65, that occurs once. 66, twice. 67, twice. 68, 8 times. 69, right now, what do we have to do? We just have to go to 80. Okay. So 69, 6 times. 70, 8 times. 71, 11. 7212, 7319, 5, 9. Come on, we got some epic music to do this.
Where's that music coming from?
The heavens,
Yeah, it's gonna say.
I think, or the room across the hall. I don't know. Take your pick.
I'm gonna go with
That
that.
If you often hear epic music in your mind when something's happening,
And you.
yeah,
They are normal distribution.
then tell somebody else, not me. I don't want to know.
No, they're not normal. Oh, maybe they are. I really don't know yet.
Okay, I'm handing back the test. Well, okay, I'm handing back the test. Yes. So the Unit 5 test properties angles times. The answer number 1 should be C, and I said it was D. So if you had C and come show me, then I will give you the mark that you deserve. Okay, but we'll do that. Okay. Anyways, let's pretend that we did this, and here are the answers that we would have gotten. Okay, 1 bar stat L1, L2. X bar, which is the mean, is 72.25. The median is 72. The mode, which comes from the table here, right, is 73. Standard deviation is 3.14. Okay, so mean, median, and mode all being very close leads us to believe that this is probably a normal distribution, right? So mean, median, mode. Okay. You can also say if the middle is 72 and I subtract 3, I get 69 as 1, 66 is 2, and 62 would be, or 63 would be 3. And if I start at the mean and go up 3, 75, 78, 81, I can see that 100% of the data will lie within 3 standard deviations. So that also, and I've got the big numbers in the middle, and I got smaller numbers on the ends. So all of that together, mean, median, and mode being about the same. If I go within 3 standard deviations, I get 62 to 81. All the data's in there. Okay, and you know, they're getting bigger. There is some little little bumps in here, but they're by and large getting larger and then getting smaller.
But then
So,
19 then 12.
yeah.
Oh, okay.
So there are some bumps and jumps, but